Yes, hello everyone. Okay, today I want to explain the another problem on Bode plot. Okay, here the problem is that is the third problem. G of h of s is equal to 4 divided by 0.1 into s plus 1 whole square into 0.01 into s plus 1. Okay, in this problem, the main thing is here the 1 by s term is absent. Okay, 1 divided by s term is absent. That is the main thing. Okay, for that what we have to do? Okay, see here. First thing is again same. There is no changes. Put s is equal to j omega in this given open loop transfer function. Then g of h of j omega is equal to 4 divided by 0.1 into j omega plus 1 whole square into 0.01 into j omega plus 1. Okay, this is regarding the first step. Next one is again there is same procedure: factor, corner frequency, slope contributed by individual factor, and the combined magnitude plot. Combined magnitude plot. Okay. Here the first thing is again here we have written the first constant. 4 is the constant, hence I have written the 4 here. Okay. Next to write the next factor, we have to take the coefficient of coefficient of s is that is 1 divided by 0.1, that is equal to 10. For this coefficient of s is 1 divided by 0.01, that is equal to 100. Okay. Out of these two, this has the least common frequency. This factor 1 divided by 0.1 into s plus 1 whole square has the least common frequency. Hence, we have selected this as the second factor and this as the third factor. Hence, I have taken the 1 divided by 0.1 into s plus 1 whole square, and again 1 divided by 0.01 into s plus 1. This is the third factor. Okay. Next, corner frequency. Again, there is no corner frequency for the constant. For this term, omega 1 is equal to 1 divided by coefficient of s, that is 0.1, that is equal to 10 radian per second. Next, here omega 2 is equal to 1 divided by 0.01, that is equal to 100 radian per second. Okay. Next, when you come to the third column, slope contributed by the individual factor. Slope contributed by the individual factor. Slope contributed by the individual factor. Okay. What is the slope contributed by the individual factor? That is 20 log 4. 20 log 4 is you are getting around 12.04 something. But I have taken the round figure here, 12 dB. And here, as we are having the s to the power 1, but here square is there. Okay. And so actually I have to take the minus 20, but because of square, I have taken the minus 40 dB per decade. Okay. If you have only s term, only one order, then we have to take the minus 20. Here square is there, and so we have to take the minus 40 dB per decade. Okay. When you come to this third factor, then we have to take minus 20 dB per decade. This is regarding the slope contributed by the individual factor. Next, last one. Here, this is the important for this problem. Okay, up to this point. Combined magnitude plot. Okay. In the last problems, what we are doing? Just we are writing that draw a straight line at 12 dB. Only we are writing that point. Okay. But in this problem, what we have to do? Draw a straight line at 12 dB. Starts from 0.1 to 10 radian per second. We have to write it. 0.1 to 10 radian per second. Okay. We have to draw the horizontal line. That line must be at 12 dB. Okay. And start from 0.1 to 10 radian per second. Because in this problem, 1 by s square, 1 by s square terms are absent. Hence, we have to write this comment here. Okay. We have to write this comment. Okay. Next, the second row, that is here as usual, minus 40 dB per decade is there. We have write just minus 40 dB per decade, starts from 10 to 100 radian per second, because we have started from the 0.1 to 10 here. Here 10 to 100. Next, for this minus 40 again we have to add this minus 20. Minus 40 minus 20 means minus 60 dB per decade, starts from 100 radian per second onwards. Okay, 100 radian per second onwards in that line starts minus 60 dB per decade. Okay, this is regarding the writing the table. We have read the equations. While writing this problem, we don't have s 1 by s square 1 by s square terms. Hence, at 0.1 12 dB, at 10 radian per second again 12 dB is there. Hence, that indicates we have to draw the horizontal line. Okay, we have to select the 12 from the 0 to 12 and draw the horizontal line from 0 to 12. Okay. If there is no, if you have this type of terms, then we have to draw the only dark line. But we don't have this type of term, hence we have to draw the dark line from point 1 to 10, and the range is at 12 degree. Okay, we have to draw the horizontal line. This is regarding the first thing. Okay, this is important in this problem. Okay, this point and this point. Okay, because here these terms are absolute. And next, when you come to the second equation, that is we are considering the 4 and these two factors. Okay, that is 20 log 4 minus 2 into 20 log 0.1 into omega. 2 into 20 is 40. Hence, I written that 40 log 0.1 into omega. Sorry. Here you have to take the range is from 10 to 100 because here we are written from 10 to 100. 10 to 100 we are written. For 10 again we will get the value as 12. For 100 we will get the value as minus 28 dB. Okay. Again the value is changing from positive to negative. Positive to negative. Hence what we have to do? We have to equate this equation to 0 and find the value. If you equate that to 0, then we are getting the omega value as 20 radian per second. Okay. This is the first answer we have got. Okay, omega g is equal to 20 radian per second. That is the first answer. Okay. Next one is third equation by considering all the factors. That is 20 log 4 minus 40 log 0.1 into omega, because again this factor is in the denominator, minus 20 log 0.01 into omega. Okay. Here the range is starting from 100 and the next value that depends upon your value. Okay. Here I have taken the 200. Here I have taken the 200. Okay. Just I will show that values as we are not getting here. Okay. If you take the 100, then the value is minus 28 dB. If you take the 200, then the value is minus 60 dB. Okay. This is regarding the magnitude plot. This is regarding the magnitude plot. Next, we will come to that phase angle curve. We will come to the phase angle curve. In that phase angle curve, okay, phase angle equation we have to write. First we have to write the phase angle equation. To write the phase angle equation, that is phi of omega is equal to, here two terms are there, hence I have written the 2 minus 2 tan inverse of 0.1 into omega, again minus tan inverse of 0.01 into omega. This is the first equation. Again, what we have to do? We have to compare this equation with respect to minus 180 degree. Minus 180 degree. Then what happens? We are getting the value as omega value as 45.8 radian per second. Okay, then phi of omega is equal to minus 180. Then this value is the second answer for our question. That is omega p is equal to 45.8 radian per second. Okay. Then after getting these two values, what we have to do? We have to go for the tabular column. Okay. What are the values we are having? One value is 20 and another value is 45.8. Okay. In between these two, we have to take the sum of values. Okay. Hence what I have done here, I have taken the directly 20, 30, 40, 45.8, 50. Okay. That depends upon if you solve the more number of problems, then you come to know that how many values we have to take. Okay. Whether we have to take the only 5 to 6 or 10 to 12. Because if you are taking the more values, then that graph will become more, then we have to account the more values in that graph sheet. Therefore, we have to select the minimum number of values here. Okay. Here, if you select the minus 138, then we can select the starting value as minus 130 and the ending value as minus 190. That is sufficient because here the difference is around 60 degree. Okay. That we have to be kept in mind. After writing this tabular column, see here, what is the omega g? Omega g is the gain crossover frequency. Hence, we are writing this g. G means gain crossover. Omega p means phase crossover. Okay. What we have to do? We have to substitute this 20 in the out of these two equations. We have to substitute this 20 in this phase angle equation. Phase angle equation will substitute model. Then if you substitute 20, then we are getting the value as 138.2. We are getting actually 138.2. Okay. For this 138.2, if you add the 180 degree, then whatever the value you are getting, that itself is the phase margin. This itself is the phase margin we are calling. Okay, we have to substitute in this gain crossover frequency in the phase angle equation. Then whatever the value we are getting, we are calling that value as phase margin. That value as phase margin. Okay. Next, we are having the 45.8, another value, that is phase crossover frequency is there. We have to substitute this phase crossover out of these two equations. Out of these two equations, okay. First equation is this is the 20 log 4, and second is this one, okay. Here in the second equation we are having the 10 to 100, and third equation 100 to 200. This 45 is in the range of 10 to 100, 10 to 100, okay. Hence we have to substitute this 45.8 here, okay. Then we are getting the value as around minus 14.39, okay. If you multiply this 14.39 by minus 1, then we are getting the value as 14.39 degree, okay. If these two values are positive, these two values are positive, the system is stable. If any one value is negative, then system is unstable. Then the system is unstable. Okay. This is regarding the this calculation, and in the next video I will show you that how to draw the graph by taking all these data.